Hello and welcome to today's webinar. The topic is a buyer's guide for availability on premises and in the cloud. My name is David Davis. I'm excited to be your moderator for today's special event. This event is brought to you by SIOS and produced by Actual Tech Media. Now, before we jump into it, just a few things that you need to know about today's event. First off, we want this to be an educational webinar, so we encourage you to use the questions box in your audience console. It's on the left-hand side there to the left of the slides window, and it says questions. In fact, I can highlight that questions box for you to call your attention to it. Of course, we appreciate all the good morning messages from everyone around the United States and across the world. But we also appreciate your topical comments and challenges that you're facing at your IT organization when it comes to availability and specifically around how to do availability, whether it's on premises or in the cloud or if it's some hybrid approach. So keep those questions coming in, and we'll be doing a dedicated Q&A session at the end of today's presentation with our expert presenter. We also have there in the handouts tab a link to the SIOS homepage. You'll be learning about the SIOS solution throughout today's presentation, and on the SIOS homepage you'll find a link to a trial that you can check out, as well as a demo and also more information. So don't forget about the SIOS link there in the handouts tab. And then finally, we'll be doing a live prize drawing for an Amazon $300 gift card at the end of today's webinar. If you're watching this event on demand, I'm sorry, the drawing has already occurred. The prize terms and conditions can be found in the handouts tab where it says ATM prize terms. And with that, I'm excited to introduce today's expert presenter. That is Mr. Michael Bilancieri, who is the Senior Vice President for Product and Solution Marketing at SIOS. Michael, thank you for being on the webinar today.
Hey, David, good afternoon. Thank you. Glad to be here.
Excellent. It's great to have you and great to have SIOS sponsoring today's webinar. I'm excited to learn about what you all have been innovating on in the area of availability for Tier 1 applications on today's webinar. Now, before I hand it over to Michael for his presentation, I want to do a little bit of stage setting here. Let's talk first about protecting critical applications from downtime and data loss. This is a challenge that so many companies out there are facing. I know when I was an IT manager, this was a challenge that we were facing, and that was quite a few years back. And that was how to keep critical applications up and running at all times. I think we in IT now are kind of looked upon as having this 0% downtime, 100% availability expectation. Our Tier 1 applications are compared to the consumer-based applications that our end users are using on a daily basis for their personal uses, things like Gmail and Facebook and Dropbox, and no matter what it is, our consumers, our end users just assume that those applications are never down. They're just always available. And they've come to expect the same thing from their critical company applications, things like SQL Server, SAP, HANA and Oracle, and no matter what application your company uses, they assume that those are just 100% available and never have any downtime. So more and more companies are dependent on these critical applications, and they have higher and higher expectations when it comes to availability. There's also greater need for availability across less mission critical applications. It used to be just our, for example, the sales processing system or the finance application or the point of sale system that had this need for high availability. But today it's pretty much every application. We want every application to be highly available, and that's become the expectation from our company executives as well as our end users. And then it's up to us in IT to find the balance between overspending. We don't want to spend $1 million for high availability for every single application we have, but at the same time, we also don't want very low availability for even less critical applications. They need to have some level of high availability as well. So it can be tough to find the right balance. Which high availability solution do we choose, and how much money do we spend to protect all of these different applications that have varying levels of availability requirements. And at the same time, once you begin your search on availability solutions, what you'll quickly discover is that the market can be very confusing. There's a wide variety of technologies out there offering some level of availability protection, particularly when cloud is involved, and they may look very similar at first glance. But what you'll discover, I think, with a more in-depth research and time spent and doing a little bit of proof of concept or demo or trial with different availability solutions, I think what you'll find is that they're all quite different. They work very differently. They're priced differently. They provide different levels of availability, and the architecture underneath is also very different. And so I'm excited about today's topic and the solution that you'll learn about from SIOS, which I think is very unique in the market. And I hope that you'll spend some time learning more about it yourself and helping to understand or trying to understand what makes the SIOS solution different from other availability solutions that are out there today. And to help us do that, I'm excited to hand it over to Michael from SIOS. Michael, take it away.
Great, thanks, David, and good day, everyone. Appreciate your time here. Hope everyone is doing well, staying safe, staying healthy, and do appreciate your time with us today. As David mentioned, we're talking about availability and really where are the changes in cloud. Talk about on-prem as well, but also how cloud drives some different challenges there. And hopefully provide you some good insights to how to bring your solutions in the right way to the cloud and provide the right level of protection to them. We look at different applications and protecting applications from downtime, from data loss. Talk about things like in past, certain level applications, lower tier applications, and now there's a lot of conversation around more critical applications and more dependency on those, and more plans to move those to the cloud. Even the less mission critical applications, as we're seeing in these times now, where we have these work from home requirements, that applications that maybe weren't so critical, they still need high level of availability, because the impact now is maybe higher when they're not available than that might have been before, or the effort to remediate those changes now. Dynamics change completely now when we don't have access to the systems, don't have access to the power of the data center, and the reliability on those systems becomes much higher. And find the right level of balance. Trying to apply a single solution to everything, all of your applications, probably isn't the right fit, and probably not the right approach. When you get to cloud, this is where things get really interesting. Cloud does make availability interesting again, and interesting in a couple different ways. Interesting in one, like, that's interesting. Yeah, that's pretty cool. We can try some different things there and some new technologies. That's one way it's interesting. It's also interesting in a, I didn't realize that wasn't possible, or, I wasn't aware of that, or that's not going to work the way I thought it was. So there's sort of two sides of that. What we're seeing in the market, can't get your thoughts necessarily here, but hopefully it resonates. And what we see in the market is the shift to cloud is obviously there. A number of years ago it was test and dev, and then the lower tier applications, more business applications. But now it's really the mission critical. The past couple of years, the tier one applications are really the focus of getting those into the cloud. Instead of keeping those on-prem in the local data center, getting those into the cloud and taking advantage of all the cloud has to offer. A lot of options in the cloud, just in general, tremendous amount of benefits. It's elasticity, there's cost savings, there's flexibility, there's ease of deployment, ease of management, a whole bunch of things. There's also a lot of different options that cause confusion, especially around availability. You have containers, you have different options that are there. You have for storage, for recovery. You have virtual machines that are very portable. You have containers, all sorts of different options, which again make cloud extremely powerful, extremely valuable to just about every business. When it comes to looking at specific solutions for availability, it adds a lot of confusion. And this is what we hear a lot when we're talking to customers and talking to folks about this. It's there's confusion. We're not sure exactly what's working, what's there, what we need, and what we're going to require for our systems. So HA in the cloud adds another dynamic of complexity. It's complex of a technology anyway, monitoring and identifying failures and then trying to recover those. When you put that into a cloud when it's out of your control and you have all these other technologies, it can become more complex. Certainly a lot greater number of options, but the complexity increases as well. You also find that moving things on-prem to cloud isn't just that easy. You can't just take a forklift and take your systems as they are, create VMs out of them and migrate them to the cloud and turn them on. Some solutions just don't work. There's no shared storage in the cloud, for example, so certain clustering won't work. And you want to take advantage of the cloud. So there's options in the cloud that you want to take advantage of. So simple lift and shift isn't typically the option. And when it is possible, it's probably not, or it's typically not the most cost-effective or efficient or even effective for your business where you're trying to go with those systems. So I want to consider that as well, that instead of lift and shift, what are the options you have to take advantage of the cloud? And David touched on this a bit. One size fits all for availability is certainly not a real or valid statement. Availability really spreads a whole spectrum and depends on your systems. I'm going to talk a lot more detail about that. It really requires a solid understanding of your systems, your applications, your users, your customers, and understanding what you're trying to achieve and what each application and system and the stakeholders require, and you apply the right level of protection for that application. When you look at cloud, just real quick, some of the things, I'm going to touch upon these a lot more, but just to give you some quick context, things that options in the cloud, some things that do exist and some things that don't. The shared storage, as I mentioned, that's not available. So the lift and shift of a shared storage cluster, you can't move your SAN to the cloud or your NAS. So that's not available. That brings some pretty significant changes to a configuration and a design of an HA or an availability solution. There's a lot of different storage options in the cloud, and there are more of them all the time. Microsoft just announced something with shared disk, and there's data protection options, moving data, there's recovery options, lots of different options here for storage and system recovery. And you have things like domains and zones and regions. Great technology, or great options. Some are technologies, some are options and configurations. The key is to understand what they are, how do you take advantage of them, and what is right to take advantage of for your business, for your applications. It could be a system by system requirement that changes, and you'll adjust based on those specific application requirements. So cloud, again, has a lot of different options, and some options that just aren't there. Real quick story, we had a customer that was migrating to the cloud, and I'm spending a lot of time on cloud here because we find that this is really the core of the conversation. The majority of our customers we're talking to are looking to migrate to the cloud, bring an SAP or Oracle or PeopleSoft or SQL Server or some critical system to the cloud. One of our customers was ready to go. They had a many-month project designing and planning to go to the cloud. The very last minute, they had to halt the project because they didn't realize their clustering technology couldn't just work in the cloud because it was based on shared storage. So we got involved and we were able to quickly identify a solution for them. But the point is there that it's a consideration that it's not always considered. It's an important consideration that just isn't always part of the conversation of how we're going to get there and what we're going to do when we're there, what will work and what won't. So we're going to talk through some of that today and hopefully help everybody here understand some of those considerations as you're in the process of or planning to or designing for migration to the cloud, that you can take some of these in consideration and prevent that from happening in your own business.
Absolutely, yeah. You make great points there, Michael. I mean, I think too many companies, maybe an executive or someone like a CIO reads an article in the newspaper, Wall Street Journal, whatever it might be, that move everything to the cloud and availability is just included and everything will be easier, and they had set these very high expectations. But when we dig down into it as IT practitioners, it's just not that easy, and it's a lot more complicated than we really envision. So I'm excited to learn more about what you're offering here. I mean, one of the questions I wanted to interject here is we as IT professionals typically have to set some level of availability, like a service level availability agreement with our business, even if it's informal. Um, and we talk about availability and high availability. So can you kind of educate us on what's the difference between availability and really high availability?
So one of the things you'll hear SIOs talk about is availability, not necessarily high availability. We offer high availability, but that's beside the point. The fact is that high availability is a relative term. How high is high enough? How high is too high? So we look at availability as a spectrum, and there's a dial right from lower level of protection to higher levels of protection, and it's going to vary based on the specific system, specific application. The thought of, well, we would just put the best, right? If we can get the best protection, the highest level of protection, we'll just put that on everything. And in theory, it sounds good. Like, why wouldn't you just want the best? When it comes down to practicality, there are costs, there are complexities, there are requirements around it that might not make it worth and appropriate for certain systems. So think about things like the impact of downtime. You got to apply these to each application, each system. What's the impact of downtime to this system? It might be higher or lower than this system over here. The impact of data loss. What's the administrative impact? Is it just a huge burden on my admin team to manage this system? What are the risks you're trying to solve for? You live on the west coast of the United States, you might have earthquakes to deal with. You live in the southeast, you might have hurricanes. In the northeast, you have other, snowstorms and tornadoes. And there's different things in different parts of the world that we have to care about. So the risks are different, and the risk tolerance as well. What can we put up with? And it comes down to your recovery points and your recovery time objectives. So those are things on the left side of the scale, things you care about. On the other side, it's, well, what do I want to put in, and what does that application warrant? What does that system warrant? The system management capabilities, and maybe it's just more of a system management function. Do I need redundancy in my systems? Do I need automation to have it fail over automatically? Or maybe backup's just fine. For some, backup is a perfect solution for availability. It might be DR, it might be the availability. That's okay, because if it's not back online for a day, 2 days, a week, maybe it doesn't matter. Backup, not high availability, but it could be the availability solution that fits just right. And there's replication. You have to automate that. You have to have a quicker recovery time. So you have to balance the costs of what you're going to implement with the needs of the application itself to make sure you're balancing those right. So it's the ROI. You could put the highest level of protection in. It's going to cost more in terms of infrastructure, in terms of maybe performance overhead, in terms of just the solution itself and the components that go with it. And the application may not warrant that. So it's really important to make sure you understand the pieces of each one and which application requires what level of protection. So when we talk about availability, high availability is part of that, but we think about it as a spectrum. And to understand where those systems fit on that scale, on that spectrum, there's things you've probably heard of this, but I think it's important to go through because there's terms that we talk about, and sometimes I forget, and people just tend to not think about these or not dig into what they are. So RTO, RPO, and nines, right? How many nines do you need? It's sort of a general thing. Oh, we got 3 nines, 4 nines, 5 nines. We got 8 nines. It's like we talk about it, or I get 4 nines from this. And when you dig into these things, really understand, you're like, oh, well, maybe that's not sufficient enough. Maybe I'm overpaying for that, and I'm not getting what I don't need that level of protection. So a couple of things here on the recovery time objective, the RTO. This is the amount of downtime, right? This is that left side of the scale we talked about. What are my objectives? What's the impact of downtime? How many users are impacted? Are they end users? Are they customers? What's the cost per minute? If it's my online e-commerce on the day before a major holiday or a big shopping day, Black Friday in the United States, if it's that day, well, that could be your business for the year, right? Your business could be totally just sunk because of that one day if the system goes down then. Cost just to repair. What's the cost per minute of your IT staff? Are you outsourcing? Is it internal? And the lost business you have, just whether it's external customers, internal business, and productivity. And then there's a reputation of the company, especially now with online and people are so quick to move from one to the other. Your system might be available now, and if it's not for a couple of minutes, that buyer might not come back. Chances are they're just going to go somewhere else and purchase somewhere else. So it's not like they'll just come back and it's okay. The reputation in the long-term business might be lost. So understanding, again, per application, because this is going to vary. Some lower tier systems, recovery time objective may be hours, days. Might not matter if it doesn't come back for a couple of days. Other systems, no, it can only be down for a very small amount of time, like moments per year. Recovery point is about data loss. So there's one part of it is downtime. How much downtime can I afford? And then recovery point is how much data can I afford to lose? If you have a high volume transactional database, you're doing online transaction for purchases or stock exchange, you can't lose data. You can't afford to lose pretty much any data, because even 1 or 2 transactions, you could lose a lot of business. And then your reputation, and then there could be, especially on a stock exchange, if there are legal ramifications, the impact from that, you have to understand that. And again, different applications, different systems, different requirements. How much data can I lose? If you put those together, generally that makes up your SLA to an end user, to the business. Our SLA is the system won't be down more than 5 minutes per year, and you won't lose more than 30 seconds, or you won't lose any data. You're going to have a solution, an availability solution that has 0 data loss, and you're going to have no more than 5 minutes of downtime per year, or 2 hours per year, whatever it might be. And again, it's important to set that per application, because you don't want to set that stringent of an SLA on a lower tier application, because if you have a major issue, a major outage, now you're trying to recover all your systems. Well, where do you start? Because you set the same SLA for every system. So now in some businesses, there are chargebacks. And so now the clock's ticking, and those lower tier ones, you know which ones to start up first, but the other ones, the lower tier ones, are still ticking the clock. Even though users don't care about it, the business, it's still ticking the clock. So really important to set those SLAs per each application. When you look at nines, you get 2 nines, 3 nines, 5 nines. The time actually adds up. People say, well, I get 3 nines or 4 nines. So, an hour a year is okay, or 8 or 9 hours, or 5 hours, or whatever it is per year is okay. And when you look at it this way, it tends to give a different perspective of it. We say 9 somewhat in a relaxed way, like 4 nines, 5 nines, 3.5 nines, whatever. But when you look at the actual meaning of that and the impact, and you say, oh, geez, if my system goes down on this day, April 15th in the U.S. for tax day, or shopping day, or whatever business, the last day of the quarter, if it goes down for 4 hours that day, boy, we're really sunk. So we have to be careful. That's not acceptable. So looking at these and understanding what is your acceptable downtime, putting the piece of timing as well, because Murphy's Law, right? It's going to happen at the worst possible time. But making sure you understand how much, when you're buying nines of availability, or when you're presenting that to your business as an SLA, it's good to understand how much time, and make sure they understand how much that is, because you might say 4 nines of availability. They think, okay, that's just about all the time. That's never going to go down. But when it goes down in the middle of whatever their closing is, or whatever they're doing, the most critical time of the year, that 52 minutes a year, that could be unacceptable. So really important to understand that, again, as you're applying it to your systems to determine what your requirements are and expressing that to your business. If you look at the pyramid here, you can see the sort of applications at the bottom, very low tier, no protection at all. You move up, maybe you have backup. And again, backup is a perfectly acceptable availability solution for some systems. It's okay if it takes me a day or two and I'm going to lose data from the last day because I back it up once a day. That's perfectly acceptable for some systems. And if that is, then probably not worth the effort and money and resources to put into putting a high availability clustering solution around it. But as you move up the pyramid, you can see the majority of your applications are probably in the lower tier, but that availability, David, to your question about the difference between HA and availability, high availability and availability, the bottom here, there's really no level of availability protection. As you move to the top, you get complete fault tolerance. It's a very, very high level of availability. Majority of your applications probably fall in the top 2 tiers. Backup is probably not enough for most of them, but you need some type of replication failover, and maybe you need it fully automated to have an RTO of seconds, an RPO of maybe 0 or maybe seconds. So different options there. But again, there's a spectrum, and it's important to to see that not every application just sits at the top of that pyramid. The top of that pyramid is hard to achieve. There are costs there, physical costs, tangible costs, as well as performance costs and management costs. If we could have it for a low price, the same as the lower tier, well, sure, why not? But unfortunately, it's not available that way.
Yeah, you make a great point, Michael. I really like that high availability or availability pyramid there, because I'm sure if the IT organization goes to the company executives and says, what level of availability do you want? Of course, like you said, they're always going to say, well, everything should be at the very top of the pyramid. But then once we start assigning dollar signs to those different levels of availability, then the business is going to be forced to make some smart decisions on, okay, well, which applications belong at which tier of that pyramid. So very, very good stuff there. That brings us up to a poll question. The poll question for everyone on the screen is, within the next 12 months, what percentage of your tier 1 applications will be running in the public cloud? And the choices here range between less than 25% all the way up to 100%, or perhaps you're just currently testing tier 1 apps in the cloud. Perhaps you will be running test and dev in the cloud in the next 12 months, or maybe you don't have any plans right now, you're still learning and researching. So I'll give everyone a moment to answer that question. We've got lots of responses already coming in. Thank you for those. Let's get just a few more. And I will share the results so you can see how you stack up with your peers who are on this webinar today. All right, thank you everyone. We appreciate those responses. Let me share the results now. And it looks like 26% said they currently have less than 25% of their tier 1 applications in the public cloud. 16% are 25 to 50, ranging on up to 8% at 50 to 75, and 2% 75 to 100%. 6% are currently testing tier 1 apps in the cloud. 8% said they'll be running test and dev in the cloud, and 34% don't have any specific plans right now. Michael, what's your take on that?
Yeah, this is about what we see. Greater than half are doing something with tier 1 in the cloud. A few customers have all their systems there. That's interesting. No plans. Yeah, I'm interested in that. That'd be interesting to hear more there too. The next 12 months. It's a tricky proposition moving those there. So maybe we're talking about public cloud, so maybe there's some private cloud there too as well. But I'd say this is probably about right where we see it. More than half are there or getting there in the next 12 months with the tier 1s. And it'll never be 100%. So this is probably right in line.
Okay, excellent. Well, I'll hand it back to you.
Excellent. So if we look at the system stack, and the question we get often is, we talk about the confusion in the cloud and moving things to the cloud. Even on-prem, a lot of solutions there that provide availability and high availability. And how do we sort of break through all that noise and figure out what's really right? So now we talked about how to determine what's necessary, what level of protection is needed in assessing your systems and applications. And then there's, okay, now we know that. Well, now what can we use? So there's a number of different options, and they sit in all different places, and they're delivered by all different types of vendors wherever they sit in the stack. So we look at sort of the rudimentary applications or system stack here, really to get a sense and talk about where availability applies. We're going to use this throughout the next number of slides. And if you think about availability, it's more than one piece. You have storage, you have network, you have system, you have infrastructure, you have application, you have data, you have all these parts of it. And any one piece that breaks, the availability solution is not successful, right? So it's not it's not a good, viable availability solution. So you want to make sure you take the different links, and there's a lot of different links, and we see it as, and most customers we talk to see it as, there's a lot of pieces I have, a lot of options I have. I'd like to use the best of breed that I see as best of breed for my environments. And that's perfect. And that's what you should do. What are the things that work for you, and what ones will work for you, and take advantage of those and work those together. Again, remembering the weakest link, that's the break in the chain. So that's your availability fault. That's your point of failure. You want to strengthen all the weaker links and make sure the whole chain is strong. If you look at the stack and where the different solutions come from, you get application vendors have solutions, OS vendors have solutions, cloud providers offer solutions, right? I list some here. Great solutions, great technologies, some of them more complete than others. Some of them aren't intended to be a full recovery solution or a full availability or a full high availability solution. They're intended to do a piece of it, like HANA HSR. It replicates the in-memory HANA database, if you're familiar with SAP. SQL Server always on availability groups. It mirrors parts of that SQL Server database. That's what it does. They're great technologies. Put them together with other pieces, they're even stronger, right? It's where the single points of failure. Cloud providers talked about the confusion that comes, or the options that come that can bring confusion. It's that interesting, like, it says the same words. It says DR, it says HA, it says failover, it says all these things that everybody else is saying. What is what? This is where it takes a lot of time and really need to do your homework about understanding what these solutions are. And we mentioned nines. One of the key things we hear all the time is, well, the cloud provider provides 4 nines or 3.5 nines or 3 nines of availability, so the cloud is HA. And as an advisor, we need to inform them. We don't want to sound biased, like, well, no, it doesn't. You got to buy our product. That's not what we're in the business of. We're in the business of advising customers of how best to achieve cloud migration and on-prem availability. But in the cloud, those terms, while they're not false, they're nuanced. So if you look at some of the common public cloud SLAs, for storage, they have 3 nines. Okay, that's 9 hours a year of downtime. Is that acceptable? No, there was an S3 outage a while back. Not picking on anybody. It just happens, right? Those data centers, while they're not in our control, we tend to think, oh, I don't manage it, so it's always available. It's a data center, has power. It sits on the ground in a building with electricity and networks and all the same things we deal with. It's just somebody else is managing it for us and has a whole bunch of cool tools to help that. But there's still challenges there, so you need to be careful of that. On a server or an instance or a VM, there's talk of 3.5 nines or 4 nines. And this is a place where there's a lot of confusion. We have a lot of conversation in the market about this. You have to, again, look at the details about that. Those are across fault domains or availability zones, meaning it's across some separation. It's not in the same rack, not in the same data center, not in the same building. Okay, they give that guarantee. It's not necessarily for your instance, that instance won't go down. It'll only be down 4 hours a year most. Well, it depends how you have it configured. Are you taking advantage of availability zones? Those are the nuances that are really important to understand when anybody talks, even SIOS, I'll say it for ourselves, anybody talks about nines of availability, ask the question, what does that mean? What does that imply? What does that cover? Because it might be, well, I have, 3 locations, and between the 3 of them, we'll always have something running. The next question is, okay, how do I make sure my application's always in the one that's running? And that's the tricky part. So dig into those pieces and understand where those technologies will work for you and how you tie those links of technologies together.
Great points, Michael. And that brings us to our next poll, and that is, what's the most important part of the stack to protect? And this could be a tough question to answer. I'm curious to hear the results from this because this is a single select question, so you have to just pick one. Which part of the stack is the most important, in your opinion, to protect application, operating system, server, storage, or infrastructure? So I'll give you a moment to answer this one. I already see some responses coming in. Thank you for those. Let's get just a few more and I'll share the results. All right, thank you everyone who voted in the slides window there. If you haven't, go ahead and select the option that corresponds to your answer. Which one do you think is the most important piece of the stack to protect? All right, thank you for those responses. Let me share the results now. And the results here say 34% said the application is the most important piece of the stack to protect, followed by 22% that said infrastructure, and a variety of other options there. Michael, what's your take?
But what really matters is the application. And we say that you can have a heartbeat at the server. Your building can be up, power can be on, the rack could be running, network could be going. It can be a heartbeat pinging the system. Even the operating system could be responsive. If the application's not responsive, this quote unquote system is down. I think about my system. If I get into Outlook and I can't get to email, I call up and say, hey, Exchange is down. I call IT, tell them Exchange is down. I don't know what it is. I don't know if the building got an issue, the power, the network, the application, the operating system, but it's the application. The system could have a heartbeat. OS could be okay, but to the end user, the application's down. The SLA clock is ticking at that point because the application is not available. So again, loaded question. All your answers were right. It's important to protect everything in the stack. But what you really want to try to achieve, is that the application is the top, and that's what's really the focus. Let's drill into that a little bit. We're going to use that same stack metaphor. You look at a sort of XY axis, the bottom being recovery time, slower on the left, faster on the right, and then your different monitoring levels in the stack going up on the left-hand side. Now, if you start with the infrastructure at the bottom, if you're only monitoring the infrastructure, you're just making sure the lights are on, the network's going in the building, the building's not on fire, whatever. Okay, that's great. But there could be all sorts of things going on inside. The rack could not have power, the cable could be out, the storage could have a problem, and the server that you're running. So just monitoring the infrastructure, which nobody probably does, but that would be very low level of recovery time because it's just a failover, and it's going to take you a while to figure out your application might not be running because there's a lot of other things that could happen even though the infrastructure is still good. But failover, if the infrastructure goes down, yeah, you can fail that over. That's a slower recovery time. Moving up, you have storage. Now, storage is an interesting one because you could have on-prem, you have a SAN or NAS, and it's very fast to recover. It has RAID, and it's monitoring if there's bad disk or bad blocks. It's just going to recover that very fast. So that's over to the right. On the left-hand side of storage, you might be just doing backup. Maybe there's nothing there, and somewhere in the middle there's replication. But storage is a level to monitor. But again, if you're only monitoring the storage, you're able to check and respond to storage issues, but you don't know if parts of the stack above it are functioning as they should. Now, when you look at the server, a number of people said we should check the server. Certainly, you should keep an eye on the server and make sure it's functioning and available. If they're just doing a heartbeat, if you're just pinging it to see if it's available, you have a quorum somewhere that's pinging it, and if it's there, it's great. If it's not, okay, it'll restart it somewhere else and fill the app over. A lot of times, that's not the issue. When the application isn't available, the server is usually just fine. So again, if the server is down or it doesn't have a heartbeat, you fail it over. Again, it's a pretty big hammer to fail over. Failing over is costly, it's expensive, and it's risky. But again, sometimes it's needed. But at the server level, you're just monitoring that and not the application and parts above it. Now you get into the interesting parts. Now at the operating system level, if you're monitoring the operating system software, so maybe it hung, maybe there's a memory issue, maybe something got in a loop somewhere and just got hung up. So you can, if you're monitoring the operating system, you have more options here. You can try to restart services. That's pretty quick, pretty low risk, right? Just trip a service and restart it. If that doesn't work, okay, now you can take the next step. Let's just reboot the machine locally. Everything seems to be okay. I can get to the server, just something's not running the OS, the application's not running, or the operating system's not responding right. Let's reboot it. Okay, chances are that's going to fix it. Much lower risk because I don't have to fail over. All my storage is local. I don't have to fail over and recover it and get all my systems in sync and aligned. And I don't have to fail back because that's another big risk and another large effort to get that system back over to the primary system. And if a reboot doesn't work, maybe there is a major issue and the system's just gone. Okay, you can still fail over, right? The last effort. But you can take a sequenced approach to what you need to do to make sure that system comes back as quickly as possible. If you're monitoring at the application level, actually looking at the application, what's running, what services are running, what's not running. Again, you can restart services, very easy. How many times, if you have a PC, do you go into Task Manager in Windows and just kill a process just because there was a service that was hung up, something's not running, and then restart the app? Well, that's easy. Very low risk, very quick. No issues with storage, no issues with redirecting users. as a failover would. So you have much greater control using smaller and lower impact recovery mechanisms. Again, restarting a service, reboot the server. If the application still won't come back, reboot the system locally. If that doesn't work, there's other problems. The storage, something's underneath not working. Okay, now you can fail it over. Failover should be the last alternative. So the higher you go up in the stack from a monitoring and recovery standpoint, you get a much quicker response because you can see things more quickly. You know the application is either running or not, and you can see what's in it, having hooks into the application to know what should be running. You can identify more quickly, so you can recover more quickly. You can use a much lighter weight approach, or start with that anyway, so your recovery time is quicker and less risk as well. And then if you have to go all the way to failover, okay, fine. But if you don't, no need to fail it over. You have risk of data issues, recovery issues, especially in complex systems. We have multiple systems that are all tied, like an SAP environment. You might have a Oracle backend, and you have the control systems, and you have all the different applications. Things have to start in order. Failover is heavy. Failover is risky. It takes a lot to make that happen, and then fail it back. So monitor the application, take the smallest and least risky recovery mechanism you can, and then move down your options. So this is where the stack, the question was, again, a little bit leading, a little bit loaded. No wrong answer. You want to keep an eye on all these things. If there's a storage issue, you want to make sure the data is protected. If there's a server issue, you want to make sure that there's protection there. But what we often forget about is getting up into the application and monitoring there. Because again, heartbeat at the server could be okay, even the operating system, but the application is just not responsive.
All right, Michael, this has been really educational. I appreciate your insight on how to look for the right availability solution, that not all availability solutions are the same, and then the different tiers of availability. I think that's really important for us to fully understand. So now I'm hoping that we can dive a little bit deeper into more detail on the SIOS availability solution and how it works. So what can you tell us?
Sure, I'll just take a few minutes here to give folks some introduction to what we do. Stuff I've talked about already, the 5 core tenets of availability. We think they're important across, not just for SIOS, but for any solution you use. These are things that we see. We've been doing this for 20 years, so we know it probably better than anybody. That's not to brag. That's just, it takes a lot of understanding of systems, of just configuring availability of operating systems, of the cloud, of applications. One of the key things here is application awareness. And I touched upon that application in the last slide. If you don't know the application, you can't monitor the right parts of it to make sure it's running appropriately and that users are connecting and it's performing as it should. So that's one. So it takes longer to discover issues. And on the recovery, you don't know what to recover locally. And then when you recover if you do have to restart or fail over, there's a sequencing that has to happen. You get into the more complex systems and environments. There are multiple systems and multiple faceted environments. Things have to start in the right order. The data has to be in the right order when it comes up. It has to be in an app consistent state. It has to be synchronized with the application. All the different servers around it have to be synchronized. Users have to be able to get to it. Redirecting users over can be tricky, and getting users to connect to the application. And making sure it all happens quickly, if you don't have awareness of the application, that's going to be a problem. Being open is very important to us because, as one of the earliest slides mentioned, all the different solutions there are. It's not saying you shouldn't use those, just use SIOS. It's saying use what's best for you. And if we can integrate with some of those, like we can take a Windows cluster and we can let you move that to the cloud. You might say, well, it used shared storage. You said shared storage doesn't exist. We can replicate the storage and sort of trick, quote unquote, Windows clustering to see 2 local storage devices as the same device, and you manage your environment. So it's pretty much a lift and shift, but now we're going to replicate the data. So now you have a very good solution that you're familiar with, tried and true, very stable in Microsoft Windows clustering, and you can move that to the cloud, and you remove the single point of failure of that shared storage. Integrating with the solutions you have and what you want to use or you're looking at is really important. We don't want to shoehorn something into you that maybe isn't exactly what you want. You have a technology you want to use. You're using SAP, you want to use their HANA system replication. Great. So find what you want to use and find solutions that are open and allow you to do that and meet your requirements. Flexibility, talked a lot about costs and SLAs and balancing that. Really important. It's not one size fits all. Don't go find one solution to say, I guess I have to use this, or the vendor says I have to use this. Go find what's right. We'd love to say, yep, you need the highest level of availability, full comprehensive cluster on every system, and you can only buy it from us. We'd love to say that from a financial standpoint, but that's not true. We would never say that. You want to find the right solution. We tell customers often, you don't need us on that, or you need this, just put this lower end. We have a much less expensive solution, easier to use, and it's simpler. That's all you need. Or you don't even need us on those systems. You're good with what you got. Ease of use. Here's an interesting one. We said availability is complex. Cloud makes it even more complex. You try to go span clouds, or you try to span hybrid cloud from on-prem to cloud, and a lot of companies are doing DR to the cloud from on-prem. That's great. Again, the options are just endless, and it just takes out single points of failure and reduces our risk and dependencies on any one vendor or any one technology. So ease of use is important. There are solutions you can bolt together. You can bolt them and make them work, and that's great. Some people like to do that, and you can get it to work. The challenge is keeping it working, right? So one, you got to get it working, and then every time there's maintenance or any update comes, you have to make sure it works again. Do all your testing, do everything you did the first time, make sure it all still works. So there's an ongoing cost to that. We believe out of the box, automated setup, deployment, application integration is really key to make it work. If we have to roll our own every time and build our own, it's really hard to do that. And then you go to a different application and start over, it's extremely complex and time consuming. And comprehensive, you probably don't have one type of operating system. You probably don't have one environment. You probably some in the cloud, some on-prem. You're probably running a mix of Linux and different Linux and Windows environments. Find something that fits all of those, and that you can match again with those different solutions we talked about, all the different things that are out there and available in the cloud and from the application vendors. Find what's right and find something that will work to, again, take all those links, strengthen the links, and make an extremely strong chain of availability up and down your entire stack. Real quickly, we'll just talk about our solutions, again, with the same stack metaphor here. If you need a full cluster, full comprehensive cluster that you want to manage the storage, whether it's in the cloud, on-prem, whether it's hybrid, HA, DR, SIOS Protection Suite gives you full orchestration, application monitoring, data protection, synchronous and or asynchronous. The whole stack, full cluster, gives you everything you need for Windows and Linux. You might say, well, I have a storage system I'm using. I'm on-prem. It's a SAN or NAS, or I don't need data protection. Well, Lifekeeper is the orchestration piece that's within the protection suite. You can implement that on your own shared storage, or maybe in the cloud there's a replicated storage you want to use, like SAP's HANA system replication. Put Lifekeeper on there and provide high availability protection for application recovery and system recovery. So again, teasing out the parts, so you're putting in the piece of that chain that you choose to use. And on the storage piece, you put an HSR there, or whatever one you choose. SIOS Data Keeper is the replication engine within the protection suite. I touched on this briefly a slide or two ago. This supports something like Windows clusters. But Windows clusters doesn't migrate to the cloud. You can't just move it there because it relies on a shared storage environment subsystem. Data Keeper does the mirroring, can do synchronous or asynchronous, or both. You do HA with a third DR component, and basically it's transparent to the cluster, so you can bring Windows failover clusters to the cloud the same way you have it on-prem. So your learning curve is lower. All the testing you've done, it's already there. You know it works. You're all set. You can move to the cloud. And you can see the different parts of the stack here, the gradient in the bars is protecting at a different level. If you go to the right, you have Lifekeeper for a single server, and it's only the application in the operating system. You might have a VMware HA, for instance, and you have it configured. It's just managing at the server and down, so it's doing a heartbeat. You want to add application protection and something that's really knowledgeable about the application to track that. We find from our customers' feedback is most of the issues they have are at the operating system or the application level. And even for systems that don't need a high availability level, they might want to enhance the availability where it's just a burden because the application freezes, services are getting stopped, users are calling, it's not responsive, and the admin has to go in, figure it out, and resolve it. Well, Lifekeeper, just in a single server mode, it can take care of all that. So while it's providing availability, it's also reducing all the administrative burden of having to deal with those very common issues. It's not building redundancy. Maybe you have another solution that's building redundancy. It's just another cluster technology. It's just not going to the application layer. This provides up to the application layer. So it's one server, no data protection. It's not doing a heartbeat. It's not failing over. It assumes you either have another solution doing that stops at the server, and we're adding the next level, enhancing that, or you don't need failover. Your RTO is really high, so it doesn't need to be highly available. You don't need redundancy. Maybe you have backup, but those day-to-day operations, you want to just reduce the task and the burden that's putting on the teams. SIOS AppKeeper is an AWS EC2 solution. It's SaaS. Notice the bar is the same as Lifekeeper for a single server. This is a SaaS solution. We launched it a few months ago. It is only for EC2, does very similar things to Lifekeeper. It's very simple. You can do a free trial online at our website. There's nothing to install. It's SaaS. There's no backend. There's no agent. It uses AWS services basically to monitor any application you have running in Windows and Linux. And if an application or a service within the application stops, we'll attempt to restart it and get the application going again. If it's not successful, you have the option of rebooting. So same as Lifekeeper, just a different form factor and different environment. Lifekeeper does support AWS, supports all major clouds, and AppKeeper does too. We built it SaaS and just started with AWS at that level. So high availability on the left, moving to the right, less level of protection, but it's enhanced availability. It may be just sufficient to add to another clustering solution or add to your backup or add to a DR capability where that application only needs a level of DR. The real key here is application knowledge. I mentioned this, so I'll be brief on this. We have what we call application recovery kits. That's our real intelligence that digs into the application. It understands the application. We have dozens of them to make sure that it identifies failures, recovers from failures, and recovers the system if it has to fail over or restart somewhere. Make sure that it does that correctly. That's the key aspect, knowing the application and knowing how it operates and the best practices for recovering it and starting it up and bringing it back online is key to making sure the system's going to come back up. You know, there used to be a saying, it probably still is, I guess. I haven't been in the backup space for a while, but backup's not important. It's recovery that matters. But kind of the same thing with availability. You can put a system in place that does HA, but if it can't restart it, or if it gets jammed up when it tries to recover because something didn't start right, then it's not really a true availability solution. It should be automated and come back up in the right order so your system's back online and users are connected. I mentioned DR and HA. That's a whole nother session. We should do another session just on HA and DR. Different technologies. Sometimes you want just DR. Sometimes you need HA and DR. You probably want some level of DR. Customers a lot of times using cloud just for DR to back up data, replicate data. But in the cloud, we get questions often, well, what does your product look like on the cloud? How does it configure? It's similar to if it was, you can do synchronous or asynchronous. These can be in different zones. We recommend highly, and most deployments are across zones at a minimum. For asynchronous, where the latency supports that, synchronous replication, so zero data loss. You can do across regions. Typically, this would be asynchronous. You're going much further distance, it's higher latency. So you can do an asynchronous replication and recovery there as well. So you can do a one-to-one for just HA locally or DR, just that, or two nodes HA and a third node DR. You can mix and match those again, on-prem, cloud, Azure, Google, AWS, you can mix and match them. We support all the different the cloud vendors, the three primary, Google, AWS, Microsoft. We have customers running in others. We don't necessarily care too much about the cloud. We do have some interactions there we care about. One of the big things to consider is how do you get users from one to the other? So whatever solution you're putting in place, whether it's SIOS or anybody else or your own, the trick and the tricky part is getting users. If you're on-prem and you're going to fail over to a cloud, how are you going to get users redirected there? If you're in a cloud, how are you going to redirect to a different zone or a different region or from one cloud to another? That's the tricky part. And there's each cloud provider has different ways to do that. There are load balancers and different mechanisms to get DNS and IPs redirected. That's a key aspect. So whatever solution you're looking at, make sure it understands how to do that, and that whatever you're trying to achieve, again, on-prem to cloud, cloud to cloud, whatever, that it can handle that, and that your failover will work, and that you fail back. Don't forget that. That's another piece. Where we bring a massive differentiation is talked about ease of use. It's automated. Failover failback is critical. You want to be able to fail back and do that as automated as possible. And the others I think we talked a lot about. So I think that just to wrap it up, we're really running out of time here. Some key takeaways. Understand the RTO and RPO of each application. Do you want HA? Do you want DR or both? Again, we didn't go into that a lot. We can talk more. If you'd like to talk more, please reach out. My email address is at the end of the deck. Think about domains, zones, regions, on-prem. How are you going to bring these systems together? How are you going to configure this? And what about your automation requirements? Is manual okay? Some systems it is, because your recovery time is long enough that manual is okay. Typically, automation is important to get things failed over and failed back. What systems do you want to use? Do you want lift and shift or refactor? And if you're going to refactor, there's a learning curve. As much as you can lift and shift and take what you have, well, that saves on retesting all your systems and applications and training your staff. So it helps to make things easier when you go there and once you're there. And think about storage and data protection. That's a big part of it, and make sure that that meets the recovery time. If you have a low recovery time, chances are you have a pretty decent recovery point objective. You want to have that low. So just think about the data that if you're doing backup, it's going to be a longer recovery time because you have to manually recover. Snapshots, it's slower. Manual is slower. Again, different solutions out there. They work very well. Just depends on what your needs are. In the end, I'll leave you with this. Find what meets your needs. If that's SIOS, great. We'd love to help you out. If not, find what meets your needs. We think we have a solution that fits most needs. Again, we can help strengthen those links in the chain and build a complete chain end-to-end ourselves if you need to. But find what meets your needs for your individual applications. And I hope this helped you in your journey of that. The folks that are testing cloud or moving to cloud or in cloud, or if you haven't not planning to go cloud, maybe this gives you some incentive to maybe you can do it. And one of the biggest concerns we hear about customers moving to the cloud are, I don't have the ability to get the SLAs, or I'm concerned about that. The SLAs I need, because if these systems go down, it's costly. It's big trouble for us. So hopefully you found this interesting, and I really thank you for your time and appreciate your time.
Great presentation, Michael. Really appreciate all the insight there into availability solutions and how to select the right option for you and your company. While we do just maybe one or two questions, we don't have a lot of time left. I want to bring up this poll that just says, what additional information would you like about the SIOS solution? So let's see, I'll be announcing the gift card winner here in just a moment. But Michael, one question that I wanted to ask you is this possible in a hybrid cloud scenario?
It is. In hybrid could be on-prem to cloud or one cloud to a different cloud. Again, the trick is to make sure the networking works and the recovery works, that users can actually get to the system when it fails over and restarts.
Okay,
but absolutely,
good to know.
Hybrid cloud is key.
Okay. And then is this available in any of the cloud marketplaces?
It is. Oh, great question. I didn't mention that. It is. We're currently in AWS Marketplace and Azure Marketplace, and we're working on some of the others as well. Right now, it's in those two.
Okay, nice. And then let's see, probably last question we have time for. If people go to the website The link there is in the handouts tab for the SIOS homepage, and they sign up for a trial. Is that the best way to get started, and kind of what happens after that, or what's the process there?
Yeah, a couple different ways depending what product you want. The AppKeeper product I mentioned, it's an AWS, it's SaaS. You can try that out. There's a free trial button there. You can go and sign up and go try it out for a couple weeks, and if you like it, you can use a credit card to purchase a monthly subscription. So that's real easy. If you want to do a trial of one of our other products, uh, there's an option on the website. You can select that and find that information as well. Somebody will get back to you on that and help you get that set up, and probably give you a demo and answer any questions you might have. They will ask you some questions about your environment. You want to make sure, again, as I mentioned, we're a software vendor, but we also consider ourselves sort of a consultant, an availability consultant to our customers and our prospects. And so we want to make sure that we're helping you with the right solution. So look forward to having those conversations with you.
Excellent. Excellent. All right. Well, I'm afraid that's all we have time for in today's presentation. Before we go, I want to announce the winner of the Amazon $300 gift card. That's going to Keith Kunkel from Wisconsin. Congratulations, Keith Kunkel from Wisconsin. We'll reach out to you to deliver that prize. Again, I want to thank SIOS for supporting today's event. Michael, I want to thank you for your expert presentation. Thank you so much.
Thank you, David, and thanks everyone for joining us. Have a great and a safe day.
Yeah, and thank you everyone in our audience. For more information, of course, visit the SIOS website. The link is in the handouts tab, and look for follow-up information after this event. Have a great day, and we'll see you next time. Bye-bye.